In MCQ 38, this is an identification question. So compound Z has the following details. It has an empirical formula of CH2. Now do not confuse empirical formula with molecular formula and structural formula. Empirical formula is really just the simplest ratio between the atoms itself. MR of 56 going to be only valuable if we're going to have two compounds to compare. I'm going to choose the one with the MR of 56. But I'll say that the most important one here in the statement is that it can react with steam to form two alcohols of different structural formula. Now steam itself is often used together with alkene, and this is a form of an addition reaction or a saturation reaction. The following conditions of 365 was actually taught in class as well. So for hydration event, right, to be more specific, is a hydration event. We're looking for 300 degrees Celsius, 65 atm, as well as the using of phosphoric 5 acid as a catalyst. We'll end off with an alcohol. So that means that my starting compound Z must be an alkene already. So with that, A is viable, C is viable, and B is viable, but D is out because it's considered to be saturated. It's actually an alkane over here. So next one here is to make sure that after we have going for A, B, and C, make sure that they adhere to the MR criteria of 56. The MR criteria of 56. So writing out the molecular formula first, this is a C3H6 for A, and the MR of C3H6 will be 3 times 12 plus 6. And this gives us a value of 42. So I'll say that A is out. If we take a look for B, this is a C4H8. It's actually a butene. It gives us a 4 times 12 plus 8. That gives a value of 56. Is still within. And C similarly is an isomer of butene. You can see that the double bond is actually shifted. So it definitely will also have the same MR value of 56. So the last criteria here is to make sure that they actually have two alcohols after you go for saturation. So for the case of B here, let's draw out. H itself can enter in this various location. Again, my water comprised, if I draw it out, H, O, and H. We're going to split it out this way. The first H that's in green. Just change the color out to black. First H that's in green. And the remaining OH will enter to give the alcohol positioning here. So because of the double bond position, water itself can split to OH over here with green, or I can go with green at this position and blue over at the other position. Right, you can see that this itself will result in a compound that is considered to be an isomer because they have two different structural formula. So some might not be able to see, so let's draw it out. So in the first case here, alright, I'm just going to omit the hydrogen so it's a bit easier to see. I'm going to have my green hydrogen followed by my blue OH. Now another variation here could be my hydrogen entering over at this carbon and my OH entering at the end. So this does give me two different structural formula. So B seems to be the good candidate here in the running. Case of C using the same abbreviation, OH, OH, or I can have my hydrogen here and here. Now, really, if there isn't a need to draw, you can see that they're actually mirror images. They will give rise to the same structure. But again, just to draw it out so everyone could be able to see it here. Again, omitting the original H that's found in the butene. We're going to have H, we're going to have H, and we're going to have OH and OH. You can see that both of them are actually the same structure, just really mirror images. So the answer for this question here will be B. And to further anchor in the final criteria of having the empirical formula of CH2, C4H8 in the simplest form here, I'll divide everything by 4. It thus gives me CH2 as well.